have is, let's say radius of a circle is increasing at the rate of 4 centimeters per second.
Mm-hmm.
Radius of a circle, it is increasing at this rate. We have to find out the rate at which the area of the circle is increasing.
Okay.
Find the rate at which the area of the circle is increasing when radius is equal to 8 centimeters. This
Okay.
is one question type. And this is radius of circle is increasing at this rate. Rate of increase of radius. Okay.
Mm-hmm.
Okay, so how will you do this problem?
Would we take a equals pi r squared first?
Okay. A is equal to pi r square. So what do we have to find out? Rate at which the area is increasing. So we need to find out the rate of increase of the area. That means dA over dt.
Mm-hmm.
And what is this information? How will you write this information mathematically? Rate of increase of radius is 4 centimeters per second.
Uh, d by dt equals 4.
D by dt?
Not sure.
Okay. Rate of increase of radius, that means this
Oh,
is dr by dt.
dr by dt.
Yes. Okay. So rate of change of radius, that is always derivative.
Mm-hmm.
So derivative of the radius with respect to time is 4. So dr by dt is 4. Now to find out dA by dt, your area is a function of radius. This is a function of radius.
Mm-hmm.
And we are differentiating it with respect to time. So first you will have to differentiate area with respect to r
Mm-hmm.
times dr by dt.
How did you why did you put dA of r though?
So let's say if you have a function y, which is in terms
Mm-hmm.
of x
Mm-hmm.
squared plus 4x plus 3. Now let's say you want to differentiate it not with respect to x. With respect to x, you can differentiate it, right? But let's say you want to differentiate it with respect to some other variable, let's say t.
Mm-hmm.
How you remember how you differentiated with respect to another variable?
Do you just put d something over dt?
No. So now when we differentiate it with respect to another variable, first you will differentiate it with respect to x, dy over dx, times dx over dt. This is the rule. I think we need to review the concepts.
Yeah, I haven't studied this in a while. Like I haven't studied at all, so I've
It's
forgotten.
okay. And the logic is, if you really look, dx and dx cancels.
Mm-hmm.
And so what you really have is dy over dt. dy
Oh,
over dt. Dx and dx is cancelled.
mm-hmm.
Here as well, dr and dr cancels out. And what you actually have is dA over dt.
Okay.
But the reason we do this is because area is a function of radius. So first we will differentiate it with respect to radius, and then
Mm-hmm.
we differentiate radius with respect to time.
Okay.
Dr gets cancelled. Now, what will be dA over dr?
Like the value or like what it means?
Differentiate the area function with respect to r. Area is pi r square. So if you
Sorry, you
differentiate,
cut out. What did you say?
I said, so area is a function of r. So
Mm-hmm.
if you differentiate it with respect to r, then what will you get?
dA by dt?
No, no, no. You have area equals to pi r square. You
Mm-hmm.
want to find out its derivative with
Uh-huh.
respect to r.
Okay. Oh, so just 2 pi r?
2 pi r, exactly.
Okay.
Times dr over dt.
Mm-hmm.
Now we want to find out rate of increase of area when r is equal to 8 centimeters. So that means you want to find out dA over dt when r is equal to 8. So you just have to put r is equal to 8 everywhere. So 2 pi, r is 8, and dr over dt, value of
Is
dr
given.
is 4. Okay, so you can write 4 here. So your answer will be 4 times 2, 8, 8 times 8, 64. 64 pi. What will be the units?
Um, centimeters per second?
So
Wait, no, centimeters squared per second?
yes. So 64 pi centimeter square per second.
Okay. Is it okay if I take 1 minute to just look at all of that?
Yes, yes, of course.
Okay. Where was the y equals x squared plus 4x plus 3 from?
Oh, this I just used to, explain,
Oh, got it, got it. Okay.
yeah, like how do you get this dr and dr? So I,
Got it, okay. Okay, I think I'm good now.
okay, so in all the problems of related rates, you will be using this dy over dt is equal to dy over dx
Mm-hmm.
times dx over dt
Okay.
in all the problems. Now, just like this, you can have problems like this was a area of a circle. You can have volume as well, volume of a cube. They can give you that edge of a cube is increasing at this rate. Then find out the rate of increase of volume of a cube. Okay.
Mm-hmm.
And basically anything like surface area, volume, area. Okay.
Okay.
So now we will do a different type of question. So this question says particle moves along the curve 6y equals to x cubed plus 2. So there is a particle that moves along this curve. We have
Mm-hmm.
to find the points on the curve at which the y coordinate is changing 8 times as fast as the x coordinate. Is changing as fast as the x coordinate.
Six, one, as fast as the x coordinates?
As fast as the x coordinate.
Okay. So would that be like when dy over
Mhm.
dt equals dx over dt?
Okay, let's write that down. dy over dt is equal to, you said dx over dt?
Mm-hmm.
Almost there. You just missed one thing.
Okay.
Oh, sorry, I forgot to write one thing. Is changing 8 times as fast as the x coordinate. Sorry, that was my bad.
Oh, okay, okay.
8 times as fast as the x coordinate. So dy over dt is equal to 8 times dx over dt.
Okay, okay.
Okay. Okay. So how will you do this?
Um, 6y. I'm gonna turn the function into like terms of y, I think.
Okay.
Maybe first.
So the function we have 6y equals x cubed plus 2.
Mm-hmm. So y equals x cubed over 6 plus 1 over 3.
Okay. X cubed over 6 plus 2 over 6 1/3.
Mm-hmm.
Okay. We really just want to, I think we really want to solve this equation to find out the value of x and y. Find the points. So we have to find the points at which this equation becomes true for what values of x and y.
Okay, but we can't really do anything with it like that, right?
Not right now, but one thing is for sure that you'll have to differentiate this function. Then only we
Yes,
will
yes.
dy over dt and dx over dt.
Okay. Can you explain one more time how I would change the dy by dx into dy by dt?
Yes, yes, of course. Okay. So if you have, there is a function of y is a function of x, something, something. So if you have to find out dy over dt, okay,
Mm-hmm.
first we will do dy over dx times dx over dt.
Okay.
But here, this is a different type of question. Here you will not need to do dy over dx times
Oh.
dx over dt because we really want to solve this equation. Dy over dt is equal to 8 times dx over dt.
Mm-hmm.
So you can just differentiate both sides with respect to t.
Oh. Oh, so then you would get um
You remember
oh,
implicit differentiation?
sorry, what did you say?
You remember implicit differentiation?
A little bit.
Okay, okay. So here we have both sides. You can, if you have to take its derivative, 6y equals to x cubed plus 2 with respect to t, would you be
Mm-hmm.
able to take it both sides?
Yes.
Okay.
So that with respect to t,
Hmm.
so that would be 6
Hmm.
times dy by dt
Yes.
equals 3x squared
Hmm.
times dx by dt.
Yes.
Uh, and then that's it, I think.
Yes, exactly.
Okay.
Okay. Okay. So, and you have this equation already.
Mm-hmm.
Okay. So from this equation, you know that dy over dt is equal to 8 times dx over dt. So you can put the value of dy over dt here. Dy over,
Okay.
we can put the value here. So
So
6 times,
6 times 8 dx by dt
yes.
equals 3x squared times dx by dt.
Hmm. Now, remember, you just have to find out the values of x and y.
Mm-hmm.
Okay. So we need to get rid of this dx over dt. And this will actually get cancelled. Dx over dt, dx over dt gets cancelled. And now, can you solve this equation for x squared?
Yes.
48 is equal to 3x squared.
Mm-hmm. So 48 over 3 is just, and then cube. Oh, oh, it's just x squared. Okay, I thought it was cubed. It's just 4.
X squared, yes. No, plus and minus 4. Now,
Mm-hmm.
this is one of the common mistakes that students make in every exam, like in SAT or even in AP exam. Wherever you see a quadratic equation like this, x squared is equal to something, you will always get two solutions, plus and minus square root of 16. Plus and minus square root of 16. Okay, never discard the negative solution. So now,
So when will it, what type of question will the
hmm,
answer only be equal to 4 and not negative 4?
in the questions, for example, you're trying to find out distance.
Mm-hmm.
So distance cannot be negative. So in that case, we ignore the negative solution.
Okay.
Like it depends on the context of the problem because some quantities cannot be negative. Like
Okay.
one example is distance. Distance cannot be negative. So in the problems, even radius, because radius is nothing but lengths, any type of lengths, they're always positive.
But time can be negative, right?
Time, yes, time can be negative.
Okay. Got
Okay.
it.
So you have two values of x, and for these two values, we can find out the values of y. So we will get the points.
Okay.
6y is equal to x cubed plus 2. If you take positive 4, so 4 cubed plus 2, 4 cube is 64. 64 plus 2 is 66. So y is equal to 66 over 6, that is 11. And if we take negative 4, so 6y will be equal to negative 64 plus 2, which will be negative 62.
Okay.
And if you simplify this, you will get 31 over 3,
3.
negative 31 over 3. So our final points will be 4, comma 11 and negative 4, comma negative 31 over 3. So these are the points at which rate of change of y coordinate will be 8 times as fast as the x coordinate. This is the final answer.
Okay.
And also in the AP exam for FRQs, I think you already do this. You write your solutions very neatly and you highlight the final answer. So that is a really good practice, especially for the FRQs, the free response questions. You should, write everything neatly and finally box your final answer.
Okay.
Okay, so this was another type of question. Then can have, okay, so this time we have a man. So there is a man whose height is 2 meters. A man 2 meters high walks at a uniform speed of 6 meters per minute. It walks at a speed of 6 meters per minute, not second, per minute,
Okay.
away from a lamp post. Away from a lamp post,
Okay.
which is 5 meters high. Lamp post, 5 meters high.
Mm-hmm.
Find the rate at which the length of his shadow increases. Rate at which the length of his shadow increases.
His shadow. Okay.
So you'll need to draw a figure for this.
Yes. Mm,
So we have, so lamppost is 5 meters high and the man is 2 meters high.
mm-hmm.
So we can draw a lamppost. Let's say this is 5 meters and this will be 2.5. So kind of, this is the man. And if he's walking away from it, so the lamp is 5 meters,
Mm-hmm.
the man is 2 meters,
Mm-hmm.
and he's walking away from it. He's walking here.
Yes.
So if he's standing here, his shadow will form here, right?
Mm-hmm.
In the opposite direction. Okay. So something like this we have.
Mm-hmm.
At any given point, let's say this man is right here, and this is the shadow, right? This will be the shadow. From this point to this point, this will be the shadow.
Okay.
Let's say this is A, B, C, D, E. Okay. Okay, so how will you solve this question? And think about it.
Mm,
Shadow.
So dm by dt equals 6, right?
dm.
Mm-hmm.
What is m? Now here in this question, they have not given us any variables. So we'll have to define the variable. So you said dm over dt equals to 6. So what have you taken? What is m?
M is the meters.
Meters?
Mm-hmm.
But what does it represent? What is, like, what distance is it?
Like distance away from 12 or from 0.
You mean from the lamp?
Yes.
Okay, exactly. So it says he walks at a speed of 6 meters per minute away from the lamp post. So this 6 is whatever is the distance of the man from the lamp, the rate of change of that distance. Because what is speed actually? Speed
Mm-hmm.
is rate of change of distance only, rate of change of distance.
Yes.
So right now, let's say the man is at some distance. Let's say he is X units away from the lamp.
Okay.
Okay, so if he is X units away and he's walking at a speed of 6 meters per minute, this
Mm-hmm.
is X meters. So this is actually dx over dt is 6
Okay.
meters per minute.
Okay.
And we always remember, first thing, write down what is given. Okay, so this
Mm-hmm.
is given. And then write what do you have to find out. Then we will get some clarity. So what do we have to find out? Mathematically, we'll write everything.
We have to find rate of the length of his shadow increases.
Yes.
So
And we don't have any
mathematically,
variable for the length of the shadow.
yeah. So I think ds by dt.
Okay, so you're taking variable s.
Mm-hmm.
So right now, let's say at any given point of time, the length of the shadow is s right now.
Uh-huh.
And he is x meters away from the lamp, and his shadow is s meters. So you want to find out ds over dt.
Got
Okay,
it. Mm-hmm.
now we can think how to find out ds over dt.
Okay. Ds over dt would be like ds over dx and then times dx over dt.
Oh, wait, what did you say? Can you repeat that?
No, I was just thinking. I was like, I don't know if it's right, but maybe
Hmm.
over dt is equal to um ds over dx or dx over
Hmm.
yeah ds over dx times dx over dt,
Hmm. Okay.
and then
Now the problem is that we don't have the shadow function in terms of x.
yeah.
We can't find out ds over dx. Now in all of these questions, Nandana, there will be always some relationship between the two variables we are dealing with. Here we are dealing with x and s. So there should be some relation between s and x. Otherwise, we cannot find out what will be ds over dx. Like in the previous question, there
Mm-hmm.
was this relation. Y was related to x somehow. Then
Uh-huh.
only we could find out the derivative. In this question also, area was related to the radius somehow. Then only you can differentiate area with respect to r. So here the relationship is not given to us, but we need to find out that relationship.
Okay.
Okay, so can you find out the relationship between x and s? I'll give you a hint.
Mm-hmm.
Similar triangles.
Okay. Oh, so s equals some fraction of. Wait, no.
And also remember,
Uh-huh.
they will not give any information for no reason. So we have still not used this information and this information that he is.
Yes.
Yes. So
So
try.
I think it's the small triangle is getting maximized by 5 over 2.
I'm not sure what does that mean. Small triangle is getting maximized.
No, never mind. It's okay. I was just thinking out loud.
It's okay. So think about similar triangles.
Yeah. Would it be s plus x for
Hmm.
the whole base
S plus x.
times 5?
Okay.
Well, that would just give me the area of the whole triangle.
Okay. And then what will you do with area?
I'm not sure how to find. Is the length of his shadow always going to be x?
Length of the shadow is s, and x is the distance between the man and the pole.
Okay, understand that.
So, okay, do you remember the properties of similar triangles? I think this is done in geometry.
Yes, I think so.
Okay, so in similar triangles, all the sides are in proportion.
Mm-hmm.
Okay, so first of all, you need to be able to see that the small triangle is similar to the big triangle. So triangle ECD will be similar to triangle EAB.
Okay,
They will be
I
similar.
got that.
This is a common angle and right angle, right angle. So all the sides of the smaller triangle will be proportional to all the corresponding sides of the bigger triangle. Okay, so I
Mm-hmm.
can say that CD over AB will be equal to EC over EA, and that will be equal to ED over EB. Ratio
Okay.
of corresponding sides. Okay.
Okay.
Okay. So we know the value of CD. CD is 2 and AB is 5.
Mm-hmm.
EC is S and EA is X plus S. And we don't know what is ED and EB, but that's okay. We don't even need that ratio. Our work will be done with these two ratios. So now you have a relationship between X and S.
Okay.
Okay.
Mm-hmm.
Okay.
S over x. 8.
And we need to find out the value of ds over dt. Okay. Now try to find out the value, like differentiate it or do whatever and try to find out the value of ds over dt. Again, you will have to do implicit differentiation, how we did in the previous question.
Mm-hmm. So in terms of t, right?
Yes, with respect to t.
So for the left side of the equation, because it's a constant, you wouldn't be able to differentiate it, right?
Yeah,
So would it just be 0?
0, yes.
Okay. So then 0 equals.
Now, I would recommend that you first do some manipulation. Otherwise, derivating this right side will be difficult for you.
Would it just be? It's just s over x plus s, right?
Hmm. But try
Okay.
to separate s and x. Like try
Mm-hmm.
to put s on one side and x on one side.
Okay. Does the bottom say x plus 8?
X plus s.
Sorry, x plus s. Got it. Okay. I think bring it over to the other side.
Just cross multiply.
Yes, yes. Hello, can you hear me?
Yeah, yeah. What
Sorry,
happened?
my screen froze for like a minute.
Oh, okay. Okay.
Oh, and your entire screen zoomed out. Sorry, let me fix it.
Should I
Okay.
reshare it?
No, it's okay. I just had to I just had to fix it on my screen. Okay.
Okay.
Um 2x plus 2s equals 5s. Yes, that's what happened. Okay, and then we
Hmm.
could bring 2s to the other side. So it
No.
would be 2x equals 3s.
Hmm. Now
And then
take derivative on both sides.
sorry?
Now you should be like, it will be easy to take derivative on both sides with respect to t.
Yeah, we could bring the 3 down to the other side before doing that too, right?
Yeah, you can do that.
Okay. So then it would just be in terms of dt, right?
Yes, with respect.
Okay. So then 2 by 3,
Hmm.
um, oh, derivative of x.
Hmm.
So,
Dx over dt.
okay, okay. dx over dt.
We are trying to differentiate both sides with respect to t, because in the end we need to find out what will be ds over dt.
Right, right. And
And then,
then equals ds over dt.
yes, okay. Now you know that dx over dt is 6.
Mm-hmm.
So this whole thing is 6. So 2/3 times
So
6.
4. So ds by dt equals 4.
Yes, 4 is equal to ds over dt. And the units will be
Now let me scroll back up. I forgot. Um, meters per, wait, no. Meters per minute?
yes, meters per
Okay,
minute. Rate of change of shadow. Shadow is in meters. So 4 meters per minute.
okay.
Okay. I think I'll have
If you
one.
find any worksheets on this, could you please
I
put
will.
them to me?
Yes, yes, I will send you. I have lots of questions with me.
Okay, thank you.
Okay, I think we can start one more. I don't know if you'll be able to finish it because there is a next class. So in the
Okay, that's okay then.
a ladder which is 5 meters long is leaning against a wall.
Oh, there's always a ladder problem.
The bottom of the ladder is pulled along the ground, okay, at the rate of 2 meters per second. How fast its height on the wall is decreasing when the foot of the ladder is 4 meters away from the wall. Decreasing when the foot of the ladder is 4 meters away from the wall. Okay. You know, this will be kind of similar to this question because we don't have any variables, we don't have any relationship between variables. Everything we'll have to figure out.
Mm-hmm.
But first, 80% of your work is done when you draw the figure correctly. Yes.
Okay,
So there is a ladder,
so,
there is a wall.
mm-hmm. And the ladder is 5 meters long.
Hmm.
And,
There is ladder, there is
mhm,
a wall, and there is ground. This is the let's say this is the wall, this is the ground, and then the ladder is leaning against. Let's say
mm-hmm,
this is the ladder,
mm-hmm.
and if you're pulling it away from the ground, it is pulled away from the ground, right?
Yes.
Sorry, away from the wall. It is
Yeah, yeah, okay.
away from the wall. So if you pull it away, so it will be like this, the new
Yes,
position of
yes.
the ladder, right? So
Mhm.
definitely its height on the wall will decrease.
Yes.
Previously, its height was this, and the new height is this.
Okay.
So that's what we have to find out, the rate of change of the height on the wall.
Mm-hmm.
Okay.
So we're given one rate and then one base,
Hmm.
and that's it.
Yeah. And some things, the length of the ladder is given, so that means that is not changing. Ladder is 5 meters.
Yes.
What is changing? This distance is changing, and this distance will change.
Yes.
So you need to assign the variables to these two quantities, the height on the wall, like
Mm-hmm.
where the ladder is touching the wall. So you can assign a variable to this distance, anything, and you have to assign a variable to this distance.
Okay.
Anything, whatever variable you want, you can assign.
Maybe x and y.
Yeah, anything. X and Y. Let's call X as this length and Y as this length.
Mm-hmm.
Now try to write what is given and what do we have to solve in terms of x and y.
Okay.
What else
Um,
is given? Okay, what is this 2 meters per second? Bottom of the line.
dx by dt.
Dx by dt is 2 meters per second.
Mm-hmm.
And what do we have to find out?
What dy by dt is
Yes,
when x equals 4.
great. Dy over dt when x equals 4. Now,
Mm-hmm.
again, we need some relationship between x and y.
Mm-hmm.
Okay, now this is what you will have to identify. What is the relationship between x and y?
Um, between x and y. Oh, when dy by or when y is decreasing, x is increasing.
Okay. But like we need some equation between x and y. Like here, we were able to write this equation between x and s using
Yes.
the concept of similar triangles. So we need some equation relating x and y.
Hmm. Oh, I have no idea. I'm sorry.
Think about it. So you see, this is a triangle,
Yeah. Would
and
it be like x squared plus y squared equals 5? Or
yes,
square root of 5?
5 square.
Okay, 5 squared. Got it.
Pythagorean theorem.
Okay.
So you can use the Pythagorean theorem to relate x and y.
Mm-hmm.
Square of the hypotenuse, 5 square is equal to x square plus y square. Now you can differentiate both sides with respect to t.
Okay. So then that would just be 0
Hmm.
equals 2x dx by dt
Hmm.
plus 2y dy by dt.
Yes.
Okay. And then what do you mm, now I don't know what to do.
Now, whenever you feel stuck, always go back to the question and see which information you have not used so far.
Okay. How fast is the wall? Oh, when the foot of the ladder is 4 meters away from the wall. Okay. So x equals 4
Hmm.
and dx by dt is 2.
Yes.
Okay. So then that would be 2 times
Hmm.
4 times 2, so 16 plus 2y dy by dt.
X is 4. Yes. Dx over dt is 2. Yes. 16 plus 2 times y dy over dt.
Mm-hmm. So then, um, would you
16.
bring it to the other side?
Yes. And don't forget, we have to find out dy over dt.
Mm-hmm.
Hmm.
So negative 8y equals dy by dt.
Hmm. Okay. So I'll just write 0 on the other side because that makes me more comfortable. 6
Mm-hmm.
plus 2y dy over dt is equal to 0. And so y dy over dt is equal to negative 8.
Yes.
Okay.
Now, it says y is equal to 4, right?
No, no, no.
Wait,
X,
no, that's x
you
equal to
need
4,
to
sorry.
find out the value of y.
Mm-hmm.
So you need here again, this is again, you have a twist. You need to find out the value of y. Otherwise, you cannot solve for dy over dt. And for that,
Yeah.
you can use this relationship.
Okay. Oh, so 25 equals 25 minus 16.
Yes, very
So
good.
y equals 3.
Yes.
So
So,
dy by dt equals negative 8 over 3.
yes. So that would be
Okay.
3. So dy over dt is equal to negative 8 over 3. And what will be the units?
Um, meters per second.
Meters per second.
Okay.
Okay.